Let's evaluate the integral of the square root of 1 plus x squared divided by x dx. We're going to use trigonometric substitution. We're going to let x equal to tangent of theta. Squaring both sides, x squared is tangent squared of theta, and 1 plus x squared equals 1 plus tangent squared of theta, which is secant squared of theta. That's a trig identity. And then differentiating both sides here, dx is equal to secant squared of theta d theta. Let's return to the integral and express the functions of x in terms of functions of theta. Inside the radical we have 1 plus x squared, which is secant squared of theta. In the denominator we have x, that's tangent of theta. Dx is secant squared of theta d theta. Let's express this as integral of secant squared is secant of theta times secant squared of theta divided by tangent of theta d theta. Now at this point it's tempting to express secant times secant squared as secant cubed, but that is not needed because we are going to use trig identity on secant squared to solve this problem. So we're not going to write secant cubed, we'll just write secant theta, and then secant square we'll write as 1 plus tangent squared of theta divided by tangent theta d theta. Let's write this as two integrals. The first one is the integral of secant theta over tangent theta d theta, and then the second integral is going to be the integral of secant theta times tangent squared theta divided by tangent theta d theta. Now for the first integral we need to express it in terms of sine and cosine. Secant is 1 divided by cosine of theta divided by tangent, that's sine of theta over cosine of theta d theta. We can cancel cosines here. And the second integral, tangent squared over tangent is tangent, so the second integral is just the integral of secant theta times tangent theta d theta. So the first integral now is just 1 over sine, and 1 over sine is cosecant of theta, plus the second integral is the integral of secant tangent, that is secant of theta. Now recall the integral of cosecant. If you don't remember, there's a video. You can look and see how it's done. The integral of cosecant is natural log of absolute value of cosecant of theta minus cotangent of theta, plus then we have the second integral, which is secant of theta. All we have to do now is express these in terms of the original variable x. I'm going to draw a right triangle, and the right triangle, call this angle theta. Our original substitution was tangent theta equals x, which we can write as x over 1. Tangent is opposite over the adjacent. Therefore, the hypotenuse is going to be square root of 1 plus x squared. So our final answer is natural log of absolute value. Now cosecant is hypotenuse divided by the opposite. So it's the square root 1 plus x squared divided by x minus cotangent. Cotangent is adjacent over the opposite. That's 1 over x plus secant. Secant is hypotenuse divided by adjacent, so that's the square root of 1 plus x squared. Now we can further simplify this. This is natural log of absolute value of the square root of 1 plus x squared minus 1 divided by x plus the square root of 1 plus x squared, and we can simplify this by breaking down the natural log of a quotient. So we can write it as natural log of absolute value of square root of 1 plus x squared minus 1. There's no need for absolute value here because what we have inside it will always be bigger than 1, but it doesn't hurt to keep it there, minus natural log of absolute value of x plus the square root of 1 plus x squared plus a constant of integration c. For more videos,